Alright, so objective 6.3 is that you are going to model exponential behavior. The point of this entire unit is this objective right here. So look at our example. In 1992, India had an estimated population of about 886 million and was growing at a yearly rate of 1.9%. Part A is going to ask us to make a function out of this. So remember, A represents the y-intercept or the initial value. In word problems, think initial value. So in this case, the initial population was 886 million. We don't need to put in all those zeros, so we're just going to put 886. The B is the multiplier. Now, you practice doing this. The B is not 1.9, it's 1.9% growth. So that actually means that B is equal to 1 plus 0.019, which is 1.019. So that's 1.9% growth as a B. So 1.019. And then finally, we can just write our function here because we know our function is a times b to the x. Now, you can write f of x every time. You can change it to t. It doesn't matter because in the next line, you're going to have to define that. So just for simplicity, I'm going to write f of x. But if you wanted to write p of t for people and time, that's fine too. So f of x is equal to 886 times 1.019 to the x. Now, after we write our function, we need to say what it's measured in. We've got two things here. We've got x and we've got f of x. So where blank is blank measured in blank and blank is blank measured in blank, those are the two different things. So I usually start with the x. X is almost always time, but not always. In this case, it is though. So x is time. And you can see time is measured in years. They're giving us years, but it's not just years. It's years starting in 1992. So if you have a starting point, you need to say when it is. We're not starting in the year 0 here. So x is time measured in years since 1992. And f of x is our function. F of x represents population. And population, of course, is measured in people. The last thing we're doing here is using our model to predict what the population is going to be in 2002. So we've done this before. We've been doing it for a while. We're just going to write f of the time, so f of 10. And hopefully you see why I use 10, because it's years since 1992. 2002 is 10 years since 1992. And what I'm going to type in my calculator is, of course, just 886 times 1.019 to the power of 10. You don't need to write this all the time, but I do need to see this because this tells me what you're doing. So f of 10, again, I'm just grabbing my calculator and typing this in, comes out to 1069, and I'm going to round this to the whole number because the initial number I was given seemed to be rounded to the whole number of millions. So that's 1069. And that's, of course, in million people, which actually means it's above a billion. So I'm gonna rewrite it in a second. 1,000 million is a billion, so the actual answer here is 1.069 billion people. Of course, you should Google that and look it up because I'm pretty sure our model is accurate. Population is almost always modeled with an exponential function. So that is it. Our objective was modeling exponential behavior. We wrote a model and then we used the model to make a prediction.